It's an interesting question about confusion over the rules of logarithms and things that follow from it. So Sam thinks that statement 1 is true, that if we have log to base x of to the power n, it's the same as log to base a of x all to the power of n. So let's see what happens if that statement is in fact true. Well, we know actually the rule of logs is that we can bring the n down, so it becomes n log to base a of x equals log to base a of x all to the n. I can now divide through by log to base a of x. I don't need to consider it equaling 0. That becomes n minus 1 because x is not equal to 1. And then we can write down that log to base a of x. Now, if n minus 1 was 2, we could take a square root. Now here, I can take the n minus 1th root, so it becomes n to the power of 1 over n minus 1. Now, there's one thing that slightly frustrates me, and the mark scheme doesn't pick up on this. If n minus 1 is even, then you would actually get a plus or a minus solution. And it is possible to get negative solution to this. It's no problem with the parameter set. The mark scheme ignores it, and I'm going to ignore it here. But if you want to investigate it more, then you could try letting a equal 9 and n equaling 3, and you will get two solutions, a plus or a minus solution here for log to base a of x, and hence x. I'm not going to go into more detail on there. We're just going to stick with this. Then finally, if log to base a of x is equal to this, then that means that a to the power of that thing on the right is equal to x, or x equals a to the power of n, which is then raised to the power of 1 over n minus 1. Sam also thinks that this is true. And now let's take a look at what happens when n is equal to 3. So it would become log to base a of x plus log to base a of x squared plus log to base a of x cubed equaling log to base a of x plus log to base a of x all squared plus log to base a of x all cubed. And we've got x1 and x2 as the two values of x that satisfy this. We need to find in terms of a an expression for x1 and for x2. Okay, now the first thing I can do is cancel out the log to base a of x by minusing that from both sides. So that's pretty good. Now I can bring the powers down. So I've got 2 log to base a of x plus 3 log to base a of x. So I have 5 log to base a of x equaling this. Just like before, I'm going to divide through by log to base a of x. So 5 equals log to base a of x plus log to base a of x squared. And this is in fact a quadratic in log to base a of x. So let me rewrite it. So this doesn't factorize. You could do a substitution if you want. You could let u equal log to base a of x, and you get u squared plus u minus 5 equals 0. I'm just going to go straight for it. Log to base a of x is going to be, I'm going to use the quadratic formula. So minus b is minus 1. There's a 1 here, plus or minus 1 squared, which is 1, minus 4ac, 4 times 1 times minus 5, square rooted all over 2. So minus 1 plus or minus root 21 over 2. And therefore, x is going to equal a to the power of minus 1 plus or minus root 21 over 2. Now remember, we had that x1 was greater than x2. And a is a positive base, I believe, or greater than 1 even. So x1 is going to be when we put the plus in. x1 equals a to the, I'm going to write root 21 minus 1 over 2. X2 is a to the minus root 21 minus 1 over 2. So those are our two answers. We're then asked to find the exact value of log to base a of x1 over x2. So that is actually going to become log to base a of x1 minus log to base a of x2. And we had this here, so the log to base a of x1 is going to be when I have the root 21 minus 1 over 2. And then it's going to be minus root 21 minus 1 over 2. This becomes root 21 minus 1 plus root 21 plus 1 over 2. So the 1's cancel, we get 2 root 21 over 2. The 2's cancel, leaving us an answer of root 21. All right, great. This leads us on to the very last part of the question. So show that if log x satisfies statement 2, this one we had down here, then this equation is true. We just did it for n equals 3, but so now we're doing it more generally. Okay, so I'm going to deal with the left-hand side first of all, which is going to become log x plus 2 log x. Sorry, I'm going to write base a, but I'm not going to say it every time. And all the way up to n log x. I can factorize out the log to base a of x, and then it's going to be 1 plus 2 plus 3 up to n. Now, this is actually an arithmetic series that is just worth knowing the formula for, because it's the triangle numbers 1, 3, 6, 10, and so on. It's a half n, n plus 1. Very useful for counting up your first n whole numbers incredibly quickly. Say 1 to 100, which is going to be a half times 100 times 101, 50 times 101, 5050. There's a story about Gauss, who managed to do this incredibly quickly when he was a school child and figured out the formula. Lots of interesting things regarding this formula. If you don't recognize it, then you can, of course, just use the ideas of arithmetic series. So a is 1 and d is 1. So then Sn is a half n times 2a plus n minus 1d, which becomes a half n times 2 plus n minus 1, which is a half n times n plus 1. But this is our left-hand side then. It's simply going to be a half n plus 1 times log to base a of x. Let's take a look at the right-hand side. So in fact, this is a geometric series. But normally when we write down a geometric series, we actually have, let me change the color, a plus ar plus dot 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 plus ar to the n minus 1. See, I've got a power of n here, so I'm just going to make one adjustment and factorize out a log to base a of x. So then I'm going to get a as 1. And this will become n minus 1. It's now in the right sort of form, so I'm going to have a equal to 1 and r equal to log to base a of x. And here the sum to n is then a 1 minus r to the n over 1 minus r. So a is just 1, Therefore, I'm going to get 1 minus log to base a of x all to the power of n over 1 minus log to base a of x. And sorry, that shouldn't have been a equals, that should have been a times. So let's bring this together. Therefore, a half n plus 1 times log to base a of x, that was the left-hand side, is equal to 1 minus log to base a of x to the n over 1 minus log to base a of x times by log to base a of x. Now let's just remember what we're trying to get to. So I can cancel out these, and then I'm going to multiply through by 1 minus log to base a of x. Therefore, a half n plus 1 times 1 minus log to base a of x, which is going to become this. And I expand the bracket. I can multiply through by 2 and then expand this bracket, n squared plus n. Not this one. See, I've got to keep track of what we're actually trying to get to. Leave this one as it is. And therefore, if I get it all on the left, so I've got 2 log to base a of x to the n minus n plus 1 log to base a of x plus n squared plus n, and now I can minus that 2 there, and we've got the result that we wanted. So remember, this is like a more general result of what I had with the n equals 3. Really nice solution. Well done.